Get ready to have your mind blown by the wildest facts in chemistry. Now I know what you might be thinking. Chemistry class? Bunsen burners? Memorizing the periodic table? But what if I told you the world around us is a giant, non-stop chemistry experiment? Bubbling potions, colorful smoke, popping reactions just waiting to be discovered? We're talking about science that looks like straight-up magic, but I promise you, it's 100% real and honestly, 1000% awesome. Forget the boring textbook stuff. We're diving headfirst into the explosive, colorful, mind-bending side of chemistry. Today, we're going to uncover 5 of the most unbelievable chemistry facts that will make you see the world in a completely new way. Let's get started. Alright, first up, let's talk about a metal that seems like it's straight out of a sci-fi movie. You've seen the T-1000 from Terminator 2, right? The liquid metal guy that can melt and reform? Well, we have something pretty close to that right here on Earth, and its name is gallium. Now, most metals you think of, like iron or copper, have super high melting points. You need a furnace or a blowtorch to get them to turn into a liquid. But gallium is the weird, cool cousin of the metal family. It looks like a solid, shiny piece of metal, just like aluminum, but it has an absurdly low melting point of just 85.6 degrees Fahrenheit or 29.8 degrees Celsius. What that means is, if you just hold a piece of solid gallium in your hand, your own body heat is enough to make it melt. It's an incredibly bizarre and cool sensation to feel a solid object literally puddle into a silvery pool right in your palm. It's completely non-toxic, so it's safe to handle, though it can leave a bit of a gray stain, kind of like pencil lead. This unique property is because the bonds holding the gallium atoms together in its solid crystal structure are pretty weak, so it doesn't take much energy, like the heat from your hand, to break them apart and let the atoms flow freely as a liquid. This isn't just a cool party trick, though. Gallium has some really important applications. So you have this element that acts like something from the future. It challenges our whole idea of what a metal is supposed to be. Next up, we're going to make fire appear out of thin air. Well, not exactly air, but with just 2 simple substances: potassium permanganate, glycerin. No matches, no lighters, no external heat source needed. This is one of the most visually stunning reactions. Mixing those two. It starts slow, then suddenly erupts into a brilliant burst of flame and smoke. Chemical surprise party. So here's how it works. Potassium permanganate is a strong oxidizer. Think of oxidizers as chemical bullies stealing electrons. Glycerin is a simple sugar alcohol. Sweet, viscous, found in soap and food, packed with carbon atoms and hydrogen atoms. You pour glycerin onto the dark purple crystals. At first, nothing happens. It just sits there, gooey. But a battle for electrons begins. Potassium permanganate rips electrons from glycerin. That oxidation releases a lot of heat. Seconds to a minute pass as heat builds slowly. The glycerin reaches its auto-ignition temperature. It bursts into flame by itself. No spark needed. When it ignites, you get a show. This is called a hypergolic reaction. Substances that ignite on contact. The same principle is used in some rocket engines, a beautiful, chaotic demonstration of stored chemical energy. Have you ever wanted to send a secret message, just like a spy in a movie? Well, you don't need any fancy gadgets from Q Branch. All you need is a lemon. That's right, the secret to invisible ink has been hiding in your kitchen this whole time. This is one of the oldest and coolest chemistry tricks in the book, and it works because of a very simple chemical principle. The process is easy. You squeeze some lemon juice into a bowl, dip a cotton swab in it, and write your secret message on a piece of paper. Once the lemon juice dries, it becomes completely invisible. The paper looks blank. So how do you reveal the hidden words? All you need is a little bit of heat. You can use a light bulb and iron, or even carefully hold it over a stove burner, with adult supervision, of course. As the paper heats up, your invisible message will slowly start to appear, turning a toasty brown color as if by magic. So what's the science behind this spycraft? Lemon juice is a weak organic acid, specifically citric acid, but it also contains sugars and other carbon compounds. When you write with it, you're applying these compounds to the paper fibers. When they dry, they're colorless. But when you apply heat, you're causing a chemical reaction called oxidation. The carbon compounds in the dried lemon juice break down and oxidize much faster than the paper itself. This oxidation process releases carbon, which is what you see as the brown color. Essentially, you're lightly charring or caramelizing the lemon juice before the paper has a chance to burn. This trick works with other acidic fruit juices too, like orange juice or even milk, which contains lactic acid. It's a fantastic demonstration of how a simple change in conditions, in this case adding heat energy, can trigger a visible chemical transformation. It's the kind of experiment that feels like a magic trick, but once you understand the science, it's even more impressive because you know exactly why it works. Now we're moving into the supervillain territory of chemistry. We all know that acids are dangerous and can burn through things, but there's one acid that is so uniquely corrosive, it's famous for its ability to do something most other acids can't: dissolve glass. Hydrofluoric acid, or HF. This stuff is seriously no joke. One of the most dangerous substances in a lab, not just corrosive, but it attacks the human body. Its most famous party trick: reaction with glass. Most acids are stored in glass bottles. Concentrated sulfuric acid in glass, no problem. Concentrated nitric acid in glass, no problem. HF is different. The fluoride ion in HF is incredibly reactive, hungry for silicon atoms. HF molecules attacking silicon dioxide. The fluoride ions break the glass down, forming new compounds: silicon tetrafluoride gas, hexafluorosilicic acid. The acid eats the glass, solid glass turned into gases and chemicals. Never store HF in glass containers. Keep HF in special plastic bottles, polyethylene, Teflon. Artists and manufacturers use HF to etch and frost glass for designs. But this stuff is terrifyingly dangerous. A small splash might not burn right away. Fluoride ions soak through tissue. Once inside, they bind with calcium ions. They also bind with magnesium ions. Consequences: severe deep tissue damage, bone destruction, potentially fatal heart attack from electrolyte disruption. A chilling reminder: fascinating reactions can be hazardous. A true Jekyll and Hyde substance. For our final fact, let's make a color-changing potion in the kitchen. Red cabbage contains a molecule called anthocyanin, which changes shape and color depending on the acidity of its environment. Just boil some chopped cabbage to get a deep purple liquid. Add an acid like vinegar, and it turns bright pink. Add a base like baking soda, and it shifts to blue or green. It's a stunning visual of an invisible property, acidity, and proves you don't need a high-tech lab to see chemistry in action. And there you have it. From a metal that melts in your hand to a cabbage that unlocks a rainbow, the world at a molecular level is a wild and wonderful place. Science is about looking at the ordinary and seeing the extraordinary hidden just beneath the surface. Stay curious and let us know in the comments which fact blew your mind the most. Don't forget to subscribe for more explosive science.